you. So this question is from IB and it generally comes in 1B paper, which is analytics and database questions. We say uncertainty principles. So the question says that a student investigate the oscillation of horizontal rod hanging at the end of a vertical string. The diagram shows the view from above. So it's like this, like this string has been attached to the rod and this rod is oscillating and then we are recording it. The student starts the rod oscillating and measures the largest displacement for each cycle of the oscillation of the scale and time at which it occurs. The student begins to take measurements a few seconds after releasing the rod. The graph shows the variation of displacement x with time t since the release of the rod. The uncertainty for t is negligible. So there is uncertainty in x, whereas uncertainty in t is 0. On the graph above, draw the line of best fit for the data. So first, we have to draw a line that will be passing from the all of the points. So we will be drawing like this. You can draw it in a better manner, but on the screen, I will be doing like this. Okay. So like this, it will be drawn and we will delete it. So it will be, this graph will be used. So calculate the percentage uncertainty for the displacement when t is equal to 40 seconds. So at t equals to 40 seconds, you see that at t equals to 40 seconds, there is a little bit uncertainty. So first we have to calculate. So one box, calculate that one box, we call it least count also, that this is 1, 2, 3, 4, 5. So 5 boxes is 2 centimeters. So 2 upon 5 is equals to 0.4 centimeter. So here you can see that how much is this. So you can take any example like this because it is a percentage. So you can see a little bit more. So this smaller box can also get divided into 4 parts and it's at the little bit here. So we can say that this delta x here is 0.5. Okay. So if delta x is 0.5, we have to calculate the uncertainty at t equals to 40. So that formula is delta x upon x into 100. So delta x is 0.5 divided by x. What is the value of x when it is here? So what is the value? This is 1, 2 and 3 and it is like 0 0.4, 0 0.4, 0.8 and half 0.2. It is 1, so it is 3.0. So we can take like this 3.0 into 100. So it will be, let's see, 0.5 divided by 3 into 100. So it would be 16.6, 16.67%. So this is how we have to do the percentage uncertainty. Now the next part says that the student hypothesis that the relationship between x and t is by this x equal to at, where a is a constant. To test the hypothesis, x is plotted by 1 by t as shown. Okay. So x is equals to a by t like this. So the question now says the data point corresponding to t equals to 15 seconds has not been plotted. Plot this point on the graph. Okay, we will do it. So when t is equals to 15, what is the value of 1 by 15? Because this x-axis it is 1 by t. So let's do it. We will do 1 divided by 15. It is 0.006. So we can take it as 0.07 as a round off. Okay, just check again. It is 0.0666 and 7. So we will take the round off digit. Now we have to first check this one box. This one box is how much value? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So we have here 10 boxes and total of 0.05 divided by 10. So here it is like one box is equals to 0.005. So from here, if you will move to this, it will be 0.06 and it will be here. So this point will be 0.07. So we are here. For this point, we have to make the graph. And it says plot this point on the graph above. Okay. See. So when this graph has been plotted, this is like y equals to mx and plus c, like, and this c is 0 because it would be like passing because there is no c here. So the graph will be like this. So we have to make the find the value according to this. We can draw again. Yeah, we have to go with the maximum of the covering the points like this. Okay. So at here it would be like this. So this will be like this. So it would be for here, like this was for this. Now on the y-axis we will see that 1, 2, 3, 4, 5. 5 boxes for 2. So it would be 0.4, 0.4 centimeter one box is equals to like this. So here this is 8.4, 8.8 and something 9. So 9 will be this point. I'll just maximize a little bit so you can check again. So it is little bit low, so we can take 9. Okay. So this is the point that we need to plot this on the graph. So this is the graph plot. This is the point that we need to plot. Okay. So this point is how much? 0.79. Suggests the range of values of t for which hypothesis may be assumed to be correct. See, hypothesis will be correct only if it will be straight line. So if you will draw this straight line is coming up to this one. After this, otherwise if you will draw a complete line like this, I'll just rub it to give you a better stance, give you a better information for that. See, if you will draw like this, so this line is not a linear line, so this line is wrong. So the right line that we need is a straight line. So it would be like this up to only this point. So this point like here, and for this it would be here. So these would be the coordinates that would be the range for t. Now we have to calculate it. Okay, so how we will calculate? Now see, 1, 2, 3, 1, 2, 3, 4, 5. 5 boxes into what was the value of one box? 0.005. We will check it afterwards. And then 1 2 3 4 5 6 7 8. 8 walks into 0.005. So it would be like 5 into 0.005, that is 0.025, and the other will be 8 into 0.005, it would be 0.04. So these are the range points. So this is how we have to solve. So hope this question would be now understood by everyone. So if you still have some questions for this particular question, you can comment below, or you can join me on the one-on-one classes so we can discuss further. If you still have some doubt, you can put it, and if you have new questions, still you can give me so I can have more videos for you. Thank you for watching this video.